Today's lesson is on building transfer functions using the TF command in Matlab. Let's start by typing help TF. So TF is creation of a transfer functions or conversion to transfer functions. It outputs the transfer function equals TF is the command. We need to give it a numerator polynomial and a denominator polynomial, and that's just a vector of the coefficients of each. I have three examples here. We'll go through all one by one. We'll start with example 1, which is a normal transfer function where the polynomial has all the coefficients. So in this case, example 1 here, I'll build the numerator polynomial. I'm just going to build a vector where I pull off the 2, the 3, the 4, and the 6. So num equals 2, 3, 4, 6. Then I got to grab the denominator, 1, 8, 1, 5, 10. Den equals 1, 8, 1, 5, 10. And then I just build the function using TF. So F equals the TF command, num, comma, den. And there it is. It should exactly match what the function is over here. It's a good way to check it, right? 2s cubed plus 3s squared plus 4s plus 6, that checks. S to the fourth plus 3s cubed plus s squared plus 5s plus 10, and that checks. Let's go after the second example where we're going to be missing some of the powers of s. In this case we have 2s cubed but no s squared termed. And on the denominator we have fourth, third, squared, and s, but no s to the 0 term. Like here we had a constant 10. We're missing an s to the 0 term. How do you do that in Matlab? You have to account for all powers of s. So in this case we would go num equals 2. We don't have anything for s squared, so we actually have to put the 0. And then we have the 4 times s and the 6. And the denominator is 1, 8, 1, 5. And again, we don't have anything times s to the 0, so we have to put that 0. Now we can build our function g using the TF command, num, comma, den. And there it is. Again, we can check it. 2s cubed plus 4s plus 6, that checks. S to the fourth plus 8s cubed plus s squared plus 5s, and that checks. So let's do example 3 now, where maybe we have a scalar out here multiplying the numerator, and then maybe they, instead of showing, like we could have factored out this s here in example 2, but they didn't. This time they went ahead and factored out the free s's, and there was 2 of them. How would you account for that? So for scalar multiplication, we can just simply multiply the entire numerator array or vector by the scalar. So in this case, let's go num equals 3 times, and then just put the coefficients in as we see them. 2, 3, 4, and 6. And then the denominator, how do we account for the 2 free s's? You just have to put zeros for as many free s's as you have. So here we have 1, 8, 1, 5, and that's the coefficients, and there's 2 free s's, so 0, 0. If I had 1 free s, I'd only use 1 0. If I had 3 free s's, I'd use 3 here at the end. Build our transfer function h equals TF num, comma, den, and it checks. All right, obviously 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 6 is 18. That all checks. And if we factored out 2 free s's, we'd be left with s cubed plus 8 s squared plus s plus 5. So that works as well. This concludes the TF demonstration.